Welcome to Study Loop.
All right, greetings. In this problem, we're given electric potential V as a function of x, y, and z, and then asked to find the electric field. The electric field is equal to the negative of the gradient of the electric potential V. So that means that the x component of the electric field will be equal to negative of the partial of V with respect to x. So if we hold y and z as constants and take the derivative of the electric potential with respect to x, for the first term we will have ay. And don't forget we take the negative of this whole thing. So for the first term, we're going to get ay. For the second term, we'll have 2bx. And for the third term, there is no x, so we'll have just 0. So for the component of the electric field in the x direction, the x component will be equal to minus ay plus 2bx. The electric field in the y direction, the y component will be given by partial v with respect to y. So if we hold x and z constant and take the derivative with respect to y, for the first term we'll have ax. For the second term, there is no y term in y in the second term, and for the last term we'll have c. So the y component of the electric field is equal to minus ax minus c. The z component is also equal to the partial v with respect to z. But normally we would hold x and y as constants and take the derivative with respect to z, but there are no z's. There's not a z in any one of my terms, so v does not depend on z. And the electric field in the z direction is 0. The z component of the electric field is 0. So here's my electric field components for x and y and z. Now, where is the electric field 0? Well, that is where all the components are all equal to 0. So if we to solve for that, we need to set each component to 0. So we solve this one first for x. We'll get minus c over a. And if we stick that into this expression here and solve for y, we'll have minus 2b c over a squared.